Hello everyone, this is the second lecture on matrix. In previous video, we have discussed about matrix, type of matrix and operations on matrix. Also discussed the property of matrix addition. And we have discussed commutative law, associative law. And now we go for additive identity. Okay, so additive identity. If A is a matrix of order m by n and O is a null matrix of order m by n, it means both have of same order. Then A plus O is equal to O plus A equal to A. Okay, here O is null matrix and we know that what is null matrix? It means a matrix which has all elements 0. Okay, so now we go for additive inverse. If A is a matrix of order m by n and minus A is the negative of same order, then A plus minus A is equal to O equal to minus A plus A. So here minus A is additive inverse of A. Okay, so now we go for fifth property, cancellation law. If A, B, and C are three matrices of order m by n, then first one is A plus B equal A plus C. So here we see that in both A is in left, so we can cancel A from left side. Then we get B equal to C. So this property is known as lap cancellation law. And now we go for second. B plus A equal to C plus A. So here we see that A is in right side. So we can cancel out A from right. Then we get B equal to C. So this is known as right cancellation law. So is that clear? Okay. Now we go for properties. Now we go for properties of multiplication of matrix by a scalar. So first one is distributive law of scalar multiplication of a matrix addition. If we have two matrices A and B of same order and K is any scalar, then this property says when we multiply by a scalar of A plus B, then it distributes on both. So this will come Ka plus Kb. Okay. Now we go for checking property. If A is a matrix of order m by n and AB are two scalars, then A plus B A. Here is distributive on both. So this will come A plus B B. Okay. We can write it as small a capital A plus a small b capital B. Okay. Now we go for third property. If A is a matrix of order m by n and A, B are two scalars, then A, B, A is equal to A, B, A. Okay. And the last property is if A is a matrix of order m by n and K is an scalar, then minus K of A equal to minus R K of A is equal to K of minus. Okay, so these are the four properties of multiplication of matrix by scalar. Okay, so is it clear? Now we go for next. Now we go for some examples. First one is find the column number of rows and number of columns of the following matrix. So here in the first the first example is we have to find the number of rows in number of columns. So here we see that there is only one row, and how many columns are here? There are four columns. So number of row is 1 and number of column is 4. Is that clear? Now we go for second. Here we see that number of row is 1, 2, 3, 4. So here number of row is 4 and number of column is 1. So is that clear how we can find the number of rows and number of columns in a given matrix? Now we go for third part. Here how many rows are there? There are 2 rows. And how many columns are here? There are 1, 2, 3, 4. So there are 4 columns. So is that clear how we can find number of rows and number of columns? Now we go for example 2. Find the order of the matrix. And I told you in previous lecture that the order of matrix is given by number of rows multiplied by number of columns. If here we have 3 rows and 3 columns, so order of this matrix will be 3 by. Is that clear? Okay. So now we go for next. These are some questions from exercise 1. So the first question is, if A is equal to this, B equal to this, and C equal to this, then prove that A plus B plus C equal to A plus B plus C. So here we have A equal to this one, B equal to this, and C equal to this. Now first we find B plus C. So B plus C will be this one, 3, 7, 4, 8, and C is minus 1, 1, 0, 0. So first we add B and C, then the first element is added B. Second, first element of second matrix. So this will come 3 minus 1, and then this add with this. So 7 plus 1 is 4 plus 0 and 8 plus 0. Then we get B plus C is 2, 8, 4, 8. So is that clear? Now we add A and B plus C. So here is 1, 0, 2 minus 1 plus B plus C is 2, 8, 4, 8. So this will come 1 plus 2, 0 plus 8, 2 plus 4, and minus 1 plus 8. So we get A plus B plus C is 3, 8, 6, 7. And we say this, we have to prove that this. So let us take this. This is first equation. Okay. Now also, because we have to find A plus B and then add C. So first we add A plus B. So we have A is 1, 0, 2, 1 and B is 3, 7, 4, 8. So first we add it 1 plus 3 and 0 plus 7, 2 plus 4 minus 1 plus 8. Then we get 4, 7, 6, 7. Okay. So now we add C in A plus B. We have A plus B is 4, 7, 6, 7. And C is minus 1, 1, 0, 0. Then we get 4 plus minus 1, 7 plus 1, 6 plus 0, and 7 plus 0. So this will come 3, 8, 6, 7. And this is an equation 2. And from equation 1, we have also 3, 8, 6, 7. So it means both equations are equal. So this proves that A plus B plus C is equal to A plus B plus C. So is this question is clear to you? Okay. Now we go for question number 2. Here it is given that A is this one and B is this one, and we have to find 2A plus 3B and 5A minus 3B. So now we go for first part, which is we have to find 2A plus 3B. So first we calculate 2A. So this is multiplication by scalar. It means when we multiply the scalar in a matrix and we multiply each elements of matrix by that scalar. So here this is 2, so this will come 2 multiplied by 2, 2 multiplied by 3, 2 multiplied by 4, and 2 multiplied by 5, and we get 4, 6, 8 minus 10. Okay, so we get 2 is 4, 6, 8 minus 10. Now we find 3b. So 3b, here b is 8, 9, 6, 7. So we multiply this 3 in each element of b. So we get 3 multiplied by 8, 3 multiplied by 9, 3 multiplied by 6, and 3 multiplied by 7. Then we get 24, 27, 18, and 20. Okay. So now we add 2a plus 3b. So this will come 4, 8, 6 minus 10 plus 24, 27, 18, and 20. Then we get 4 plus 24, 6 plus 27, and 8 plus 18, and minus 10 plus 21. So this will come 28, 33, 26, and 11. So the value of 2a and 3b is 28, 33, 26, and 11. So is that clear how we can find the value of 2a plus 3b? Now we go for second part, which is 5a minus 3b. So here we have a is 2, 3, 4 minus 5b is 8, 9, 6, 7. So first we find 5a. So this will come 5 multiplied by 8. So 2, 3, 4, 5. Now we multiply each element by 5. So this will come 5 multiplied by 2, 5 multiplied by 3, 5 multiplied by 4, 5 multiplied by minus 5. So this will come 10, 15, 20, and minus 25. So the value of value of 5 is 10, 15, 20, and minus 20. Also find 3b. 3b is 3 multiplied by this matrix. So this will come 24, 27, 18, and 20. Now we subtract 3b from 5a. So we get this is minus 10, 15, 20, minus 25, minus 24, 27, 18, 20. Then we get 10 minus 24, 15 minus 27, 20 minus 18, and minus 25 minus 21. And we get minus 14, minus 12, 2, and minus 46. So the value of 5a minus 3b is equal to minus 14, minus 12, 2, and minus 46. Is that clear? Okay. So now we go for next. Question number 3. Find a plus b and show that a plus b equal to b plus a. Okay, where a is this and b is this. So first we go for part first. We have a equal to 7, 9, 9, 2, 3, 4. And b is 2, 3, 4, 5, 6. For addition, first we check the order. So here we say that both a and b are of same order. Now we can add for so this will come 7, 9, 9, 2, 3, 4 plus 2, 3, 4, 5, 6, 7. Now we add corresponding element. So 7 plus 2, 9 plus 3, 9 plus 4, 2 plus 5, 3 plus 6, and 4 plus 7. this will come 9, 12, 13, 7, 9 and 11. We call this is first equation. Now we find b plus a. So here b is 2, 3, 4, 5, 6, 7 and a is 7, 9, 9, 2, 3, 4. So this will come 2 plus 7, 3 plus 9, 4 plus 9, 5 plus 2, 6 plus 3, 7 plus 4. This will come 9, 12, 13, 7, 9, 11. So from equation 1 and 2, we get a plus b is equal to b plus a. And so is that clear? Now we go for second part. Here we have a is equal to 1, 2, minus 3, 4, 1, minus 4, 1, 5, minus 3, minus 2, 2. And b is 3, minus 1, 2, 4, 0, 5, 2, 0, 3. So first we find a plus b. First we check the order. So here we see that both have same order. So now we add a plus b. So we have a is this and b is this. Now we add corresponding side, then we get 1 plus 3, 2 plus minus 1, minus 3 plus 2, 4 plus 4, 1 plus 2, 5 plus 5, minus 3 plus 2, minus 2 plus 0, 2 plus 3. So then we get a plus b is 4, 1, minus 1, 8, 3, 10, minus 1, minus 2, and 5. So this is, we call this is first equation. Also we find b plus a. So here b is this and a is this. Now we add corresponding side, and after solving we get 4, 1, minus 1, 8, 3, 10 and minus 1, minus 2, minus 1 plus 5. So this we call this is 2, equation 2. So from equation 1 and 2 we get a plus b is equal to b plus a. So is that clear? Now we go for question number 8. For what values of a, b, c, d, e, the following matrices are same. Here a is a 1, 2, c, b 3, 1, minus 1, 0 and b is this. We know that two matrices are equal when when the corresponding elements are equal and are of same order. So first we check the order of both matrices. So here the order of both matrices is 3 by 3. So now we check the corresponding. So this matrix, it is given that it is same matrix. So the first element will be equal to first element of B. So A equal to 0. Here second element of A is equal to second element of B. So it means equal to 1. Third element of A is equal to 3. So we are on question number 8. Here it is given that both matrices are for what value of A, B, C, D, each value of these matrices are same. And we know that two matrices are same if both are of same order and both have the corresponding element same. So these will be equal if first element of first row is equal to first element of first row in T. So A equal to 0 and this equal to E. So equal to 1 and this 2 equal to 2 and this C equal to this element. So this is double and B equal to this is, so which is 9. Okay. And D equal to this is, which is 3. Equal to 1 minus 1 equal to 1 equal to 0. So is that clear how we can find the value of A, B, C and D? Now we go for question number 9. If A is equal to 2, 3, 1 minus 4, B is 1, 0, 0, 1, then find 10A, 10B, 4A, A plus B, A minus B, 2A minus 3B, 5A plus 3B. So here we have equal to 2, 1, 3 minus 4 and B equal to 1, 0, 0, 1. And 10B equal to 10 multiplied by 1, 0, 0, 1. And we know that how to multiply in a matrix by scalar. So we multiply this 10 in each element of D. So this will come 10 multiplied by 1, 10 multiplied by 0, 10 multiplied by 0, 10 multiplied by 1. And we get 10, 0, 0, 10. So 10 be equal to 10, 0, 0, 10. Now we go for second part, which is 4A. It means 4 multiplied by A. So this will come. Now we multiply each element by A by 4. So 4 multiplied by 2, 4 multiplied by 3, 4 multiplied by 1, 4 multiplied by minus 4. So we get 8, 12, 4 minus 16. So the value of 4 is this. So is that clear? Now we go for third part, which is A plus B. We have A equal to 2, 3, 1 minus 4, B equal to 1, 0, 0, 1. So A plus. Now we add corresponding element. So this will come 2 plus 1, 3 plus 0, 1 plus 0, minus 4 plus 1. Then we get 3, 3, 1 minus 3. Now we go for part 4. We have to find A minus B. Here A is 2, 3, 1 minus 4 and B is 1, 0, 0, 1. Now we subtract corresponding sides. So 2 minus 1, 3 minus 0, 1 minus 0, minus 4 minus 1. Then we get 1, 3, 1 minus 5. Okay, now uh, we find 2A minus 3B. So first we find 2A. So this will be 2 multiplied by 2, 3, 1 minus 4. So this will come 2 multiplied by 2, 2 multiplied by 3, 2 multiplied by 1, 2 multiplied by minus 4. So this will come 4, 6, 2 minus 8. Similarly, we find 3B. Then we get 3, 0, 0, 3. Okay, now we subtract 3B from 2A. So this we have 2A is 4, 6, 2 minus 8 and 3B is 3, 0, 0, 3. So now we subtract corresponding side. 4 minus 3, 6, 0, 2 minus 0, minus 8 minus 3. We get 1, 6, 2 minus 11. So this will come 2A minus 3B equal to 1, 6, 2 minus 11. So is that clear? Now we go for last one, which is we have to find 5A plus 3B. So here first we find 5A, which is 5, 2, 3, 1 minus 4 is 3. So we multiply each element of A by 5 and we get 5 multiplied by 2, 5 multiplied by 3, 5 multiplied by 1, 5 multiplied by minus 4. Then we get 10, 15, 5 minus 20. Now we find 3B, so we multiply by 3 in matrix B, then we get 3, 0, 0. Now we add both, then we get 10, 15, 5 minus 20 plus 3, 0, 0. So now we add corresponding side, 10 plus 3, 15 plus 0, 5 plus 0, minus 20 plus 3. So this will come 13, 15, 5 minus 7. So is that clear? Now we go for question number 12. Find the number of rows in number of columns. So in the first part here we see that there are two rows. So number of rows is 2 and how many columns are here? 1, 2, 3, 4. So here number of columns is 4. Now we go for part second. Here we see that number of rows is 1 and number of columns is 1, 2, 3, 4. So number of columns is 4. Now we go for part third. Here we see that number of rows is 1, 2, 3, 4 and number of columns is 1, 2, 3. So is that clear? Now we go for part 4. Here we see that number of rows is 1, 2, 3 and number of columns is 1. So is that clear how we can find the number of column and number of row? Okay. Now we go for next question. Find the order of following matrices. So here we know that a matrix of the order of a matrix is written by rows multiplied by column. So in the part first we see that here number of rows is 1 and number of column is 4. So the order of this matrix will be 1 by 4. Okay. Now we go for part second. Here we see that there are 3 rows. 1, 2, 3. And there are 1, 2, 3, 4. 4 columns. So the order of this matrix will be 3 by 4. Now we go for part third. Here we see that number of rows is 4 and number of columns is 1. So the order of this matrix will be 4 by 1. Now we go for fourth part. Here we see that number of rows is 4 and number of columns is 2. So the order of this matrix will be 4 by 2. Is that clear how we can find the order of any matrix? Okay. Now we go for next question. Are the following matrices conformable for addition? We know that for addition, the both matrices have same order. So in the first part, we see that the order of first matrix is 3 by 3, but the order of second matrix is 3 by 2. So it means this is not possible. Okay. Now we go for second. Here we see that both matrices have order 2 by 2. So this is possible. Is that clear? Now we go for third part. Here we see that the order of this matrix is 2 by 3 and the order of this matrix is 3 by 2. It means both are of different order. So this is not possible. Is that clear? Now we go for fourth part. Here we see that both matrices have of same order 3 by 1. It means this is possible for addition. Is that clear? Now we go for last question. Find the value of x and y if this matrix is x3, 5x minus y and second is 2, 3, 5, 1. We know that two matrices are equal if both are of same order and the corresponding elements are same. So here we see that both are of same order. It means first element will be equal to this one. Okay, so it means x equal to t. Second is equal to this, which is equal. Third is equal to this, which is equal, and this is equal to 1. So x minus y equal to 1. So this implies y equal to x minus 1. Now we put the value of x here. So we get So is that clear? How we find the value of x and y? Okay, so here value of x is 2 and value of y is 1. Thank you. I think it is enough for today. Okay, thanks for watching this video.